Hey chaps, I hope you're all well. Today is going to be a little bit of a special episode where we're going to be tackling a couple of community requests. Those requests mainly around zooming into the Tileset Previewer and tackling a custom type converter so we can change the format of the frame rectangles in the JSON file. Additionally, there's going to be a small change to the zoom behavior to invert it because it's currently the wrong way around and it's triggering me immensely after some mentions in the comments. So without further ado, let's just get cracking. Okay, so over in Visual Studio, let's get to fixing our zoom. So in the editor project, we're going to go to the MonoGame editor, file, right click and view code. In here, we're going to scroll down to our update method and we're just going to find the little piece of code which modifies our current zoom level. The only thing we need to do is just change this plus for a minus. Okay. So now onto the meatier task of tackling the Tileset Previewer's zoom functionality. To set a bit of context real quick, we're going to start the editor. In here we can select a tileset, and as it stands right now, hovering over the Tileset Previewer and rolling the mouse wheel will scroll the Tileset Previewer vertically. Also, if you are using a trackpad, tracking horizontally will make it scroll horizontally as well. What we want to do today is add some functionality such that if we scroll the mouse wheel, it will zoom in or out depending on the direction you're scrolling. But also we don't want to lose the scrolling functionality either, so we're going to make that happen only when you hold the shift key. So to do that, we're going to do all of our work in the Tileset Previewer control. So closing down this now, we're going to go to our editor project and go to controls, and we're going to right click on the Tileset Previewer and view code. So the first and possibly easiest change we're going to make in this class today is how the picture box sizes itself. If we scroll down to the Tileset Previewer constructor, you'll see we've set the size mode to auto size. What this means is that it will change the size of the picture box to match the size of the image it is currently displaying. Now to simulate the zoom effect, what we're going to do is change the size of the picture box to be larger than the image, therefore stretch it out, or make it smaller than the image, therefore squashing it together, to simulate the zoom in and out effect, therefore auto size will not work for us. What we can use is one of two options. We can use stretch image, or we can use zoom. Now in our particular case, it doesn't really matter which one we're going to use. All zoom does over the top of stretch image is maintain the aspect ratio of the image. But because we're going to be scaling it ourselves, it doesn't really matter which one we use, but it feels a little bit more fitting to use the zoom setting, as we are trying to achieve a zoom effect. Don't be fooled, however, there is a lot more involved than just changing this setting, as I will now demonstrate. If I start up the editor project, select tileset, you will quickly realize something is very wrong. What's happening is that the tileset picture box is being created with the relatively small default size and is forcing the tileset image to fit into that picture box whilst maintaining the aspect ratio as I suggested zoom would do. What we need to do now is add some additional code to change the size of the picture box to match the size of the image ourselves, as it's no longer automatically happening. So close down the editor, and we're going to add some more code changes into our Tileset Previewer. So ultimately, our next step is to achieve functional parity with what we had previously. And to do that, we need to set the size of the Tileset picture box ourselves when the image itself changes, and that happens up here in the Tileset setter. Now because we need to add some additional logic when the tileset is present, this setter could get pretty noisy, so I'm going to move this out into its own new method. So I'm going to take this existing code here, I'm going to go to the bottom of the class and add a new method called private void onTilesetChange, and then paste that in there. And then I'm going to scroll back up and delete the code and call our new method. Okay, so back in our new method, because we're going to add some new logic when a tileset is present, I'm going to tidy this up a little bit so it reads a bit easier and is easier for us to add to. So in here, I'm going to essentially translate this into something else, which is if tileset equals null, tileset picture box image equals null, and then return. That way we know from this point onwards there's a valid tileset for us to use. So now just to achieve that parity, we're going to go for tileset tileset picture box image is equal to tileset get image from texture. And now we're doing essentially the same job as that old line of code. But now we can add additional operations underneath this line when there is a tileset, and therefore it's easier for us to add to. And the first thing we're going to do is change the size of the picture box so we have that behavior. So the first thing we're going to need is this image, and we're going to store that in a variable just to make it a bit easier for us to access. So we're going to go for image, tileset image is equal to that. The tileset get image from texture, and then we're going to assign the image to that variable. Okay, and now additionally, like I say, we set the size of the picture box. So we'll go tileset picture box size equals new size tileset image dot width tileset image dot height. There we go. And that is achieving the same behavior we used to have. We're now setting the size of the picture box to match the size of the tileset image. So let's give that a quick test run. So let's hit the start button here. Select tileset, and you'll see straight away we've got the same behavior we used to have. So now we're in much more control of it. So now if we close the editor down, maybe scale this up a little bit. So width times 2, height times 2, just a little experiment. I'll then select the full tile set, and you'll see it's scaled the image up. Now, of course, it's not working yet. The individual tiles are wrong. They're not in the correct place, and you'll see that just needs some work, and you'll see here there's all sorts of issues with that. But we'll get to that in due course. The next step we're going to take is actually enabling the mouse wheel to scroll into the tile set for us. The next thing we need to do is then handle the mouse wheel event. This is an event which fires whilst hovering over the control, and then you scroll your mouse wheel, which is a perfect opportunity for us to then start scaling the image. So if we scroll up to our onCreateControl method, in here we add event handlers for the click and paint events already. We now just need to add a new event handler for the mouse wheel event. So I'm going to type tileset picture box mouse wheel plus equals, and then tab to insert the handler. I'm going to take this new handler and I'm going to paste it at the bottom of the class with the rest of our private methods. I'm going to place it just above tileset change where we have a little bit more context, and I'm just going to remove the exception that it throws so we have a blank canvas. The next thing we need to do is then start scaling the size of the image appropriately. Now we're going to use the exact same method I showed you a moment ago where we scale the width and the height by a number, but we need to have a more defined output. Now the reason I say that is because as we multiply by floating point numbers more and more, because they get cast to integers, the more inaccuracies you will notice, and therefore as you zoom in and out it will look slightly different more and more over time. So we need to have a more determined way of zooming so we know the expected output every single time. So to achieve this, we always want to multiply the original size of the image by the current zoom level. So we need to store a few more pieces of information. So firstly, we're going to store the original size of the image. Scrolling to the top of the class, I'm going to create a new variable, and I'm going to call this a private size original size. And then we're going to set this in our onTilesetChange method. So right underneath here where we set the tileset picture box size, I'm also going to set the original size to the tileset picture box size. As we know, just set that size to the current image size, so we know that is the original size. Okay, so scrolling back to the top of the file now, we're going to create a determined list of zoom levels, and the benefit for this is twofold. Not only does it make it deterministic, it also creates an upper and lower bound for how far you want to zoom in or out, so it makes sense. So I'm going to create a private read-only list, because I don't want to change it, of floats. I'm going to call this zoom levels, and I'm going to give it some default values. Okay, so you can imagine that the zoom levels represent the current scaling of the image, so 1f is the default size of the image, its original size. If you want to zoom in, you want to make it bigger and therefore increase the number, and likewise for zooming out, you want to make the numbers smaller. So I'm going to add some new values here for zooming in, so 1.25f, 1.5f, 1.75f, and 2f. For zooming out, I'm going to go for 0.75f, 0.5f, and 0.25f. And then lastly, we want to store the current zoom level. So I'm going to create a private int current zoom level. Okay. Now to preserve the original behavior, we want to make sure this current zoom level is 1. So that is the index of 0, 1, 2, 3. And we'll set that in our onTilesetChange method as well. So scrolling back to the onTilesetChange method, I'm going to set the current zoom level to 3. So we know it's always the original size of the image. So now we have all the information we need, we can get straight to the mouse wheel event handler and do some real zooming. So in the mouse wheel event handler, we now just need to work out which direction you've scrolled the mouse wheel in. Now lucky for us, on the mouse event args E object, there is a property called delta. This delta property you may recognize from when we're doing the zoom on the MonoGame editor. This tells you which direction you've scrolled in and by how much. In our case, we don't care about how much, we just care about what direction. So our check is greatly simplified. So in our case, we just want to check to see if e.delta is greater than 0. We'll zoom in. Otherwise, we'll zoom out. And zooming in and out is really, really simple. We just need to change the zoom level. But of course, we need to keep it within the constraints of the list we created to make sure it doesn't go out of bounds. So to do that, we're just going to do zoom level, current zoom level, math.min, current zoom level +1, and then zoom levels dot, spell it properly, count -1. And then very similarly for zooming out. So current zoom level equals math.max, current zoom level -1, and then 0. Okay, so zooming out, or zooming in rather, is what goes down the list, making the numbers bigger, but we don't want to go outside the list. And then zooming out, we do the same, go backwards, but we don't want to go below 0. Okay, so the last thing we need to do here is just set the size based on the zoom level. So here we're just going to go for a tileset picture box, size equals new size, and then we need to cast to an int because we're going to pull out a float, and then we're going to cast original size.width multiplied by zoom levels, current zoom level. And then we do the same for the height. So int original size height multiplied by zoom levels, current zoom level. And that's it. That's all we need to do. However, there are a few problems we need to tackle yet, as I will now show you. So if I start up the editor, select tileset, and scroll to zoom in on that tileset, it does scale the image absolutely fine and it looks good, but the tile frames aren't scaling with it. Also, if I scroll to zoom out, you'll notice it does zoom out, but it's also scrolling the image down as well using the scroll bar, like so. So that's another problem we need to tackle. So the first problem we're going to solve is the issue of the tile frames not scaling correctly whilst zoomed in or out. Now all we need to do is scale the rectangles that are being drawn, and this is actually quite a simple task, but there isn't a method available out of the box for doing it, so we need to add our own. So in the extensions folder for the editor project, I'm going to right click, add new item. I'm going to create a new class called rectangle extensions. Okay. I'm going to call this static class rectangle extensions, and I'm going to add a new method, public static rectangle. We need to add the namespace, control period, and we want the Microsoft XNA framework namespace. Just call this method scale, and then, like any other extension method, we're going to pass in this rectangle rect, and then the only other parameter I'm going to accept is a float factor, so the factor to scale it by. Now, of course, these rectangles only work with integers, and we're passing a float, so there's going to be an issue that we need to cast. So we're going to return a new rectangle, and then the arguments for the constructor are x, y, width, and height. So we're going to take the existing rectangle, x, y, width, and height, and multiply it by the factor. So I'm just going to go for convert to int 32, as it just reads a bit nicer. X multiplied by the factor, and then rinse and repeat for each of the other components. So y, width, and then height. Okay, and that's everything for our extension method. So back in our Tileset Previewer, the changes we need to make now are absolutely minimal. So the first thing we need to do is in our Tileset Picture Box Paint, we just need to call the scale method on the frame rect so that it is scaled appropriately before being drawn. So here, when we assign it to framerect I, instead we're going to assign it to framerect I.scale, and we're going to scale it by the current zoom level. So we take the zoom levels, current zoom level. Okay. Similarly, when we're pulling out the rectangle in the click event, we need to scale that as well. So I'm just going to call framerect I.scale. I'm going to get the zoom levels, current zoom level, .contains. Just to make that a little bit easier to read, I'm going to assign it to its own rectangle as well. So MonoGame rectangle, scaled rect is equal to, there we go, and then instead of all that, it's just going to be scaled rect.contains. Okay, so let's give that another run. Hit the start button, select tile set, scroll the mouse wheel to zoom in, and see straight away the tile frames are scaling appropriately. And I can select them, it works just as intended, and I can paint them just as I always have done. So that's all working fine. Conversely, if I zoom out, ignoring the scroll issue which we are yet to resolve, it does zoom out appropriately, and I can still select the small tiny tiles that are there, and they are the correct tiles when I paint them. So the last problem we need to resolve on this particular feature is the issue of the scroll bars reacting as we're trying to zoom in and out of the tile set. If we scroll down to our mouse wheel event handler, we need to add some additional code in here to deal with that scenario. Now the first thing to bear in mind here is how these events work, and how they are working is that if I don't tell them to stop, it will continue to bubble up the hierarchy and hit all the other components. And that's exactly what's happening here. I'm rolling the mouse wheel, I'm not telling the system that I've handled the event, and it's hitting the panel and scrolling the scroll bar. So we need to tell it to stop when we're scrolling into zoom. Okay, but first of all, we only want to scroll to zoom when we're holding the shift key, because I still feel like it is valid to scroll the mouse wheel to scroll around the tile set as well. Okay, so all we're going to do is add a quick check here if modifier keys, which is a property of the control, is different to keys.shift, then we return. We only want to zoom, there we go. We only want to zoom if we're holding the shift key in my particular case. So lastly, all we need to do now is tell the event system that we've handled the event when we are holding the shift key and zooming. To do that, I need to cast the mouse event args to a special handled mouse event args. Okay, so I'm going to get handled mouse event args, handled args, and I'm going to cast handled mouse event args. I can't spell. That was so embarrassing. Handled args, and then we set handled to true, and that's it. We start up the editor project once more. Select tile set. Scroll around without using the shift key. It will continue to scroll as it always has done. And now if I hold the shift key, I can scroll to zoom in, scroll to zoom out, and it does not scroll the scroll bar at all. So it's all working beautifully. And that pretty much wraps up the zooming into the tile set feature. However, there's one more thing I'd like to show you. If I start the editor project once more, select tile set, say the full tile set, and click edit, because it's all part of the same component and control, the feature and functionality is in the tileset editor as well, so I can hold shift and zoom around in here too. And that's the beauty of writing these generic components, is that you get the benefit in multiple places, and it's just generally good practice. Okay, so just wrapping up that now, next we're going to move on to the type converter or the JSON converter for the tileset frames. Here is an example tileset. This tileset has one single frame that follows our current frame format. Our current frame format represents each frame as an object in the array, and each object has an x, y, width, and height property. Now you can imagine if you have a lot of frames, this can get very verbose very, very quickly. What we can do, however, is translate this down to a simple single string, and that's what we're going to do today. Now an example of how this frame would look as a string, I'll show you right now. So to translate that frame to a string in the format we're going to go for, it will look a little something like this. So in a string, it will have 4 numbers, the first being the x, the second being the y, the third being the width, and the fourth being the height. So a list of these frame objects can be reduced to a list of these strings, and it will look a lot cleaner. So that's what we're going to do today. So to get the ball rolling, we are first going to create our converter class. And there are multiple ways we can do this. The first of which is by using a type converter. The second is using a JSON converter. Now a type converter is traditionally attributed to the class you are trying to convert, which in our case is the rectangle, but we don't own that class, so adding an attribute to it becomes a little bit hacky. So what we're going to do is create a JSON converter. So in the engine project, we're going to create a new folder. I'm going to call this JSON converters. And in that folder, I'm going to create a new class. I'm going to call this rectangle JSON converter. Okay, so like I said, we're going to be creating a JSON converter, and there is a class for doing that. So if we extend JSON converter, and there is a generic equivalent as well, so you can specify the type you are trying to convert. In our case, this is the rectangle. Okay, we now just need to add the namespaces. So for JSON converter, I'm going to control period, add using Newtonsoft JSON. And for the rectangle, I'm going to do the same for Microsoft XMA Framework. Additionally, I can select the class name here, control period, and implement abstract class, which will give me these two handy methods which, as it would suggest on the tin, reads and writes the type to and from JSON. Now for writing the type to JSON, this is actually very straightforward for us. As I suggested in the example previously, all we want to do is write each component of the rectangle into a string, and that's all we have to actually do in this method. So I'm going to take the JSON writer that is passed to us, and then write the values of the rectangle value parameter. So I'm going to call writer.writeValue, and then I'm going to pass in a string. I'm going to pass in value.x space value.y space value.width space value.height. And that's all we have to do for the writer. So onto the read functionality now, and this is where it gets a little bit more complicated. As this is now the second format we are introducing for our frames, we must consider some level of backwards compatibility or our existing tile sets will not load. I will, however, be keeping this code completely separate, so if it is of no use to you at all, you can very easily remove it. I am, however, going to be covering it in this episode, so we have all bases covered. So to get us started, we need to work out which format we are trying to actively read. And to do that, we need to inspect the content of the reader. So first of all, we need to start making use of our converter in our live code. So I'm going to set a breakpoint on this line here, and then we're going to invoke this readJSON method. And to do that is very easy. If we head over to our tile maps, tileset class, where we actively use this, in our first call to deserialize object here from JSON file, we're going to pass in an additional parameter, and that is going to be an instance of our converter. So comma, new rectangle, JSON converter. And then we add the namespace, control period, using game engine, JSON converters. Okay? So with that done, I'm now going to hit the start button, and we should hit our breakpoint, which we have. So if we hover over the reader now, expand that, it'll tell you a lot of information about what it's trying to read, including the path. So we're currently trying to read the frames at the 0 index, and it tells you a little bit around the token it's trying to read. In this case, it is a start object, which is completely correct. If we open up one of our tile sets, what it's trying to do here is it's trying to read the first token of the first frame, and that is an opening object curly bracket. So that's what it means by start object. There is also an accompanying end object as well when it reaches the end of the object, but all that really matters to us is that we know we're trying to read an object, so that's how we know we're trying to read the old format. There is another token as well for strings, which is going to be our new format, so there's an easy way of identifying that as well. So let's close down the editor, and now we're just going to be laying the foundation for reading each format. Okay, so removing the exception, the first thing we're going to do is check if reader token type that I just showed you is equal to JSON token start object. This is our old format. Else if reader token type is equal to JSON token.string, this is our new format. Okay, so we've got a couple of conditions there, one for reading the old format, one for reading the new format. The only thing I'm going to add at the bottom of this additionally is an exception if it's neither of these, because something is obviously wrong. So I'm going to throw a new exception, and I'm going to pass a string, so I'm going to name the class rectangle JSON converter, and I'm just going to basically say invalid token, and then pass the token. So reader token type, because that is obviously what's gone wrong here. Just so we know about it if anything does go wrong. Okay, so now I'm just going to create a couple of methods so that each of these conditions can call into them. So private rectangle, because ultimately we want to return a rectangle as a result of this work. This is going to be read old format JSON reader, and then one for the new format as well. Okay, and then I'm just going to call these methods from our conditional blocks. So our old format is going to return read old format, pass in the reader, and then for the new one, return read new format, and then pass in the reader. Each of these methods are currently just going to return a new rectangle for now. Okay? So now we're going to get to filling out our new methods, starting with the read old format method. Now when we enter the read old format method, we know we're dealing with the start of an object, so we can safely turn this into what is called a J-object. From that J-object, we can then extract the individual tokens for the X, Y, width and height, and then subsequently pull out the values from them. So to create our J-object in our method now, I'm going to type J-object, add the namespace, control period, using Newtonsoft JSON link. I'm going to call this JSON object, and to create that I'm going to call JObject.load and pass in the reader. And that will read the content of the current object, i.e. the frame, into this JSON object for us. Next we need to get the individual tokens for the X, Y, width and height components. Lucky for us, on the JObject there is a handy method called try_get_value, which works very much the same as int try_parse and try_get_value of some other collection types, which can indicate to you whether it failed to find the value or not. In our case, if it fails to find any of the components, we're going to raise a suitable error, just to make things a little bit more robust. So let's get started on that now. So if we fail to try_get_value, so JSON object, try_get_value, let's start with the X component, and then as a result we'll spit out a J token, X token. Okay? Or, and then we repeat the same for the other components, any of them fail, we'll raise an exception. Okay? And the handy part of this way of doing things is that all of these variables now exist in the scope of this method, so we can then access those tokens if it does find them later on down the method. However, if it fails to find any of them, we're now going to raise an exception. So let's throw a new exception, rectangle JSON converter, not all rectangle components were found, and then what we're going to do is pass the path it's trying to read. So to do that, we're just going to go for reader.path. Let's just put that in brackets so it's very obvious. Okay? So if it fails to read any of those values, it will tell us which frame failed to read, which would be very useful for debugging. So moving on, we now need to pull the values out of these tokens. Now because these tokens are coming straight from JSON, there are no guarantees that they are in fact numbers, so we need to run another chain of checks, much like this one, to ensure they are in fact numeric. So let's get straight to that one now. So if we fail to int try_parse, let's start with the X token, so X token, and we'll have to toString this, so toString, and then out int X. So just like above, we're then going to chain these together. Okay, and much like our previous check, we're now going to throw an exception. So let's copy this exception down here, and let's change the messaging a little bit, so not all rectangle components were numeric, and then pass the reader path again. Last but not least, we now just need to put these integers that we've just created as part of our try_parse chain into our new rectangle down here. So let's enter those now. So new rectangle, X, Y, width, and height. And theoretically speaking, we can now run this and everything will work as it always has done, just using our new format parser. So let's give that a quick run now. Let's start the project. Everything's looking fine. Let's select Tileset. And here are all our frames. And this is all running through our new code. If I edit the tileset, this is all here as well and working as it always has done. So that confirms our reader is working for the old format. So now what we want to do is start adding the functionality for reading our new format, as the method is currently just returning a new rectangle. So what I'm going to do is modify one of my existing tilesets to have a frame in the new format. So heading over to one of my tilesets now, I'm going to change this, the first frame, to read in the new format. So I'm going to create a string instead of an object, and it's going to read as 0, 0, 32, 32, and then a comma, and delete the old frame. So there's my sample data. I'm now going to go back to my converter and start filling out this method to read the frame in that format. So bear in mind, when we enter this method, we know we're dealing with a string, we can just split that string by a space character and ensure it has the correct number of components to represent our x, y, width and height. So let's just do that now. So we can create a string array called components equals reader dot value dot toString dot split and give the space character. Okay. So now I'm just going to make sure the number of components is correct. So that should be 4 if components.length is different to 4. I'm then just going to raise an exception. I'm going to use the exact same exception I used in the previous old format method, which is this one, saying not all rectangle components were found. Okay, so that's reading in our components. We now just need to parse those components into the appropriate x, y, width and height. So for that, I'm going to copy the exact same chain we have from the previous format into our new method and change it around a little bit. I'm going to paste that in here. And I'm just going to change these tokens to use the various components. So for the x component, I'm going to use components 0. And then for the y, I'm going to use components 1 and so on. Okay, and all that's left to do here now is make use of these integers when we create our new rectangle, much like we did in the previous format method. So I'm just going to copy that line here. Copy that line and paste it in here. So with that said, if I give this a quick run now, I should be able to load successfully and have all my frames loaded, including the first frame, which is in a string format. If I select my full tile set, there's my first frame, which is defined as a string, and the rest are all objects. Okay, so finally, the last thing to do is make sure we use our converter on save. Up to now, we've only used it on load, and therefore when we save a tile set, we won't get the benefits of our new format. To make that change, we're going to head over to the tileset class and scroll down to our save to JSON method. In here, much like before, we just add another parameter to the call to serialize object with an instance of our converter. So I'm going to create a new rectangle JSON converter and just pass that in. To make sure this is all working as expected, I'm going to load up my JSON file from my tile set here, and I'm going to show you this change when I make some mass changes to my tile set. So I'm going to launch the editor. I'm going to select my full tile set, edit tile set, and I'm going to generate a load of new frames, but I'm going to make them smaller so it recognizes a change. So I'm going to generate loads at 16 by 16, and there you can see I've got a lot of changes. So if I hit OK now, this file has just changed to use the new format, as you can see there, right before our own eyes. So it's a lot more concise, it's a lot more packed, and this may just be a preferential thing, but I think it's easier to read. If I close down the editor and start it up once more, just to make sure it's all loading correctly, select my full tile set, and there are all my tile frames as expected. So that about wraps up the JSON converter for the rectangles. And with that about wraps up for this episode. So thank you very much, chaps. I hope you enjoyed that. It's been really good fun for me to incorporate some of your ideas. I will be doing another episode like this in future when more crop up, granted they are relevant. So please tune in for that one, and please subscribe. I hope to speak to you again soon. Ciao.